Hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms and how to do them more efficiently, how to optimize for performance, speed, robustness, diversity, all the good stuff, all the good stuff, all that jazz, actually. So, date time right now is 2025 October 13th, and in my last video I left off saying that I would need to do some sort of a grid search with the chaotic version of genetic algorithm, and then discuss the findings, observe them, and then move on to the dynamic version of the chaotic genetic algorithm, as in chaotic dynamic genetic algorithm. So for the past around 2 weeks, that is what I have been doing, because the last time I recorded this was around 2 weeks ago, and this is the first proper video that I'm doing after that. So, well, more than 2 weeks, slightly more than 2 weeks ago. So yeah, it did take a bit of time. Well, but fortunately, I think I have something to talk about. I was partially lazy, but at the same time I was quite determined to find something that I can actually talk about, some substance. I didn't want the video to be, of no substance at all. So here we go. So well, where to start? So I said that I would be doing a grid search for chaotic genetic algorithm, not dynamic yet. And the purpose of the grid search would be to, number one, well, let me just have a look at my notes. Oh yeah, the purpose of the grid search was to find the entity event, or just event ratios in short, ratios that produce true ceilings. Now, of course, this doesn't mean that whatever entity event ratios end up producing true ceilings, it does not mean that they will always produce, or rather yield, true ceilings. I just wanted to know, since a lot of it is based on luck, I just wanted to know which event ratios would do that. Since if they do it in the first couple of tries, they are more likely to be able to produce true ceilings. But just wanted to know. No. And also, while doing this, I shouldn't number it like this, but maybe I should. While doing so, observe, study the following, which are the maximum evers, meaning max of heads, also have a look at the time it takes. I just call them time taken, so have a look at the time taken, because multiple plurals, I did more than once. And also, since I'm having a look at the time it takes for one iteration to finish, then why not also have a look at the number of data points. This is not the same as a number of blips, not the same as blips, but they are correlated. They are related and correlated, and in the end, well, not in the end, I should have said that, but anyway, have a look at the world summed utility values, and also the entity distributions, including also including pop size as well. So if I have a look at the entity distributions, I also wanted to have a look at the population sizes as well. So and the conclusion, what I do want to look for is, towards the end, I'd like to I wanted to find out the combinations of as in entity event ratios. Let's just call it event ratios for now, for sure, just to make it shorter. Which combinations lead to moderately high level of convergence. Now, emphasis on the moderately, because if everything really converges really highly or a lot, then I've probably said this a million times by now, that is not good. And also, which method is better when it comes to selecting which entity to learn from for an entity. So is it flat or is it ReLU-like? And once I have covered that, I should move on to find out if the findings or the findings will the findings carry over to chaotic dynamic as well. Yeah, and for this I might have to do the entire thing again for chaotic dynamic, or just a select few event ratios. So that's it. So that's the game plan for today. I might not be able to cover everything in this video because there are unfortunately a lot to talk about, a lot of things to talk about, a lot of plots and a lot of concepts. For example, I should make this clear. What I mean by this is give me the red again. Flat. By flat, I mean when an entity needs to choose when an entity that decided to learn needs to choose another entity that it would like to learn from, and I'm talking about the chances of the other entities being chosen. And when I say flat, the top something percent would have the same probability of being chosen. So for example, if it was top 20%, and if there were 100 entities, the top 20 entities from head to the 20th entity would have the same probability of being chosen, which is 5% each, something like that. And whereas for Relu, give me purple, for Relu-like, it's not exactly Relu, but it is kind of like Relu, so that's why I named it Relu-like. This is kind of like a reminder. So here we have it. And then if it's again top 20%, starting from the head, this is where the head entity is. Same for this one. And this is where the tail entity is. And again, same. For example, 100 entities. And then if it was for top 20%, that's number 20 over here. And then from the top, for example, this is 1, and then we go down. So like that. And so the first entity would have the 20th entity would have something like 0.001 ish, and the head entity would have a relative weight of 1, and the next entity would have something like something slightly less than 1, for example 0.95, and then this would continue down, something like that. Yeah. And when we add all of this up, we will get a certain total of weights, and the head entity would have 1 over the total sum of weights chance of being chosen. The next entity would have 0.95 over the total weight chance of being chosen. The third one would have 0.90, I think, over total weight chance of being chosen. So you get the point. Now, this change, it used to be this one, but then I changed it to this, because most of the times the entities were converging too much, which is why I wanted to emphasize the word moderately high convergence. Emphasize the word moderately, because time and time again, as I've said, if it converges too much in a relatively or fairly random environment, the entities will just get struck out and just would have to go away. So that's not ideal. That's especially less ideal if things were to be dynamic or randomly dynamic or progressively dynamic, incrementally dynamic, randomly and incrementally dynamic, etc., etc. So in environments that are not that predictable, convergence at a really high level is not desirable, because you just end up with a lot of entities that have converged before an era, before a new era starts, and then as soon as the new era starts, it would have to just many entities, the majority of the entities, because of the high level of convergence, would have to be struck out, and you would have to start over again. So that's not ideal. So before, it used to be, before this change from here to here, it used to be the flat version. This is the flat version. This is the ReLU-like version. Before this change, it used to be for the top 10% flat, top 10% flat. And then what this does is that when given a fairly or a relatively smaller population size, for example 100, because before doing pseudo chaotic, it used to be it started from the smallest of the final total population size was 400, but 100 is nowhere near 400, and when the final population size is this small, the top 10% end up being the same entity, or end up having the same chromosomes, and that, in other words, means that the level of diversity is too low, again, which means that it is highly converged. So that's not good. So to fix that, another way of doing that would be to increase the percentage for the top entities that will be chosen. But then again, this had the risk of not a risk, but this had the some kind of disadvantage of choosing entities that are not quite there yet. So to fix that issue, I had to get rid of the other half of the rectangle, which is doing this. Make it a triangle. And this looks like an activation function. Nope. Give me pink. No, give me blue. This looks like an activation function because it looks like that. A ReLU activation function, to be more exact. So that's why it's called a ReLU-like. The purpose of this is to somewhat emphasize the or to guarantee that some of the top entities are chosen more frequently, but at the same time give the other entities that between the top 10% and the top 20% marks. Give them some chances of being chosen, so as to well, guarantee diversity. Has nothing to do with political correctness, by the way, but has everything to do with trying to always aim, or has everything to do with aiming for a more robust population. So that's that. That is the idea. And so, what did I do? Well, the first thing that I did is to have a look at all the things that could happen. So M stands for mutate, or mutation, mutate. L stands for learn, P stands for procreate, and C stands for chill and exist. Chill and something like exist. So for each entity, for every entity, when it has to decide what it wants to do, given some chances or ratios, which these entity events happen below, and oops. So, for example, if I were to make sure that M plus L plus P plus C equals 100, yeah, then I could just start from 0, 1, 2, 3, all the way to 100. This is the start of the logic, and the same for learn as well. And procreate as well, and chill and exist as well. And then this is where we start. Okay. Now, if I remember correctly, well, mutation, or the act of or the entity event mutate, promotes randomness, but it also provides the initial seed for the very initial seed for evolution, since procreation does not favor higher summed utility values. It does not favor entities with higher summed utility values. So what happens here is that if I set 0 for mutate, then it means that nothing will be mutating. Because, for example, if it's 0, and then learn is 50, and then procreate is what? Is, for example, it's 20, and then chill is 30 for every entity. These are the entity. This is the entity ratios. list of entity ratios, entity event ratios, and then if it were given this for MLPC, if no entities ever were mutating, because the initial entities start with void genes, this won't change. Initial 10 entities will start with this, and it will never end. Nothing changes, and every entity will just be stuck here. So this, not only will this never end, but even if I made it possible to come to an end, it would have gone nowhere, because nothing would have changed. No entities would have moved away from all zeros. So that's a no, right? So that's a no for sure. So it has to be one. Something always has to be changing. And if I were to keep everything in the integer format, the lowest for the mutate ratio is 1 until what was it? 100. Yeah. Let's just leave it at that for now. And the same for learn, or not exactly the same, but if all entities were learning, MLP, if all entities were learning, then if I wanted to keep everything so that this total sum would be 100, that's not good, because then everything is a 0 again. So automatically 100 is out, so 99, yeah. And then well, can I have 0 for the learn ratio? And the answer is yes. It could still be no learning may not encourage, or may not make it possible for entities to learn from other entities so as to make some degree of progress, but no mutation would actually mean no progress, no changing at all. So in a way, if this is 1, the learn ratio has to be 99, and if the mutation event ratio is 100, the counterpart for the learn has to be 0. Okay, so these are the minimum and the maximum values for mutate and learn. For procreate, again, we're trying to find this some combinations or combinations of entity event ratios that all add up to 100, because I would like to keep it that way. It could go over 100, but then again, since we're talking about relative weights, it's the sum of all weights that go over 100 will automatically be recalculated back to some other percentage or percentages that, when added all together, equal 100. So there's no point in doing that. So anyway, for the procreate ratio, it could theoretically be 0 to 100, but then I also tried, or I shouldn't say also, just for the sake of testing, I tried 30%, and it actually took a very long time to do this. and I do not want to have to do this again. And it does not, this number or anything bigger than this does not guarantee does not guarantee the things that I'm trying to look for. So with that in mind, the previous in the previous versions of genetic algorithms, the usual num to create, as in the number of entities that are to come or that are to be introduced as newborns from other pre-existing entities, were always somewhere about 5 to 7%. So in this case, I just set the number for procreate event ratio to 3, 4, 5, and 6. Okay. And for chill and exist as well, for example, it cannot be 100 because it means that nothing will be doing anything but chill and exist. So nothing will be happening. No changes, no learning, no procreating. So that's a no. So 99. And then 0 from 99. So when I do this, something like this, let's see, I have, let me see, where's the cursor? Oh yeah, so it's 0 to 99, but then that's going to be too much. The next logic was that if 99% of them, of the entities, were to be just chilling and existing, that's too much. So I also slightly changed it a bit, and then set it to set the initial numbers to 0, 10, 20, 30, 40, and 50. So 6 numbers. So here we have 100 numbers. 100. For the learn, again 100. For procreate, it's 4. And for chill, it's 6. So it's 24. And then 4 zeros trailing off that. So, and where is it? Now, back to using this. If it's 240,000 to be exact, and then suppose it takes about 40 seconds for one iteration to finish. Okay, so 40 times 2 is this number. And well, what is this? This is 9.6 million seconds. 9.6 million seconds divided by 3600 equals, so 96 divided by 60, which will be out minutes, divided by and then 60 minutes, so that's an hour. So in other words, this becomes 3600, right? And then this gives 2666.666666 days, hours actually. And then divided by 24 is going to take 26666 divided by 24 to convert this into days would have taken 111 days, 0.1111 days. So this is not feasible. I can never do this. Well, maybe I can, but no, not at this moment. Anyway. So, give me. Is it gonna be so? Yeah. So that's not good. I need to sneeze. Okay, I'm back. So there's no way I'll be able to do that. But then I remembered that I want to keep everything in such a way that they all add up to 100. And then given these two, I could find out the exact combinations that give me 100 total weight. And if I do that, I get 240 combinations, or 240 event ratios. So it went from 240,000 to 240 event ratios. So in theory, I could do this in 2.6 hours. So 2.6 hours for flat 20%. That's once. 2.6 hours for ReLU or ReLU-like 20%. That's another 2.6 hours. And then times 2. And then just for fun, or maybe not so fun, but still, just to compare, once with flat top 10%, that's also 2.6 hours. So that's what I did. And then I have to admit, while I was doing this, I made some mistakes, and then I ended up doing flat, was it 20%? Yeah, so I ended up doing flat 20%, 20%, and 10%. So that's 3 of them. So these are what I'll be comparing, and this could, just by accident, and let's just call this a happy accident. I could use this as a kind of like a baseline where no learning happened, just by the nature of the mistake that I made while I was reprogramming stuff. No learning ever happened in these 3 iterations. And then I was wondering why the scores were so low, but I made a mistake. So that's that. Yeah. So first I think I need to show the well, this should do the trick. Yeah. No. No. Yeah, I'll just start with the wrong one. 7-1, 7-1. Yeah, why not? So this is give me no. Actually, sorry. I didn't do that. Okay, fine. Snaps. There we go. So, for now, to begin with, I need to show the types of entity. Not types, but all the entity event ratios. So to do that, I'm going to copy this and paste it here, and then copy that, and then bring this over here, and then zoom in. Hope things. Nope. That doesn't show. I'm so bad. Just an example, but I still think I need to show this. Right now, we are going to have a look at, just have a look at these numbers right here. And here. That was first two. 1, 2, 3, 4. One, 2, 3, 4. I need 2 more. Five, 6. And then copy this. Copy this. There we go. So sorry for the delay. Let's have a look. And since this is all, let's. Oops. There we go. So let's have a look there. If you look closely, it all starts from this one. I'll put this. We're starting from here, this one, and then we go down, 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 and then when we're at the end right here, we go back up, to this one, and then we start from here, and then we go down. So you get the point. So the first, I'm not going to go all 200, and I shouldn't have to go through all 240 entity event ratios, but this is what we start with. The first one is 196, 3, and 0, and then the next one, see how this adds up to 100. The next one is 11, 86, 3, and 0. So again, this adds to 100. So notice how the ratio for mutate increased by 10, and the ratio for learn decreased by 10, while the ratios for MLPC, the ratios for procreate and chill, remain the same. So this will go on for 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, until the very end, where mutate is 97 and learn is 0, and procreate and chill is 3 and 0 respectively. And also notice how the lowest value for mutate is 1, not 0. As I said, 0 for mutate ratio means that there will be no change at all, because the evolution iteration always starts with void genes, void chromosomes. So, and then when this is over, the event ratio for procreate is increased by 1, so it goes from 3 to 4, and then the rest of the ratios are set to equal 100 when added up together again, and then everything increases and decreases by 10, and this goes on for 10 times. 10 event ratios, and when that is done, the P is increased by 1 again, and again on and on and on for another 10 times. When that is also done, 5 to 6, P is increased, and that's it, because P is set to 3, 4, 5, or 6. So that's all of this column, the right column, the far right. And then when we've done that, the value for chill, the last event ratio, the chill ratio is increased by 10. So it went from 0 to 10, and then all the rest of the event ratios are changed so that the total sum of weights is 100 again, and then we have these ratios, corresponding ratios. When we've done that, 3 is increased to 4. When we've done this, 4 is increased to 5. You get the idea. 5 to 6, and then the chill ratio is increased to 20. When we've done this column, 30, after that 40, up until 50. Now this is how we have 240 event ratios that we can kind of go through in order to do the grid search. GRS. Okay. So, since I think I need to make this into 2 or 3 videos, I think I will share. I'll try sharing. Yeah. Okay. So first, what should I share? Let us have a look at the maximum errors. Yeah. Because that's this, I think, is the, well, this is why I'm kind of doing this for this, but maximum errors. Let's have a look at that. So the first thing I did was what was the first thing I did? There we go. Rel twice. I did the rel first, twice. I did this first, top 20%, rel like twice. And the first one is give it. There we go. This. Now, if you look closely, here you have the entity event ratios, and each dot here, each data point here, represents the maximum that ever existed during this iteration, during that 30 to 70 seconds. I say 30 to 70 seconds because the time isn't always 40 seconds. But anyway, I'll talk about that later. But yeah, let's invite this to the Windows Paint. Here we go. Yeah. So in the first row, in this row, we have the chill ratio, which is 0, and then the procreate ratio will go from 3 to 6, and then the M and L, the ratios for M and L will always be, oscillating, or will always be giving and taking back and forth. As you can see here, it starts from, the M starts from 1, and then 11, 22, need to zoom in for that, 1, 11, 22, 33, 43, 54, 65, 75, 86, 97, and then for the L, learn, it decreases by 10. And here, what we can see is that usually the highest max ever, or the highest max of heads, rather, highest max ever, let's say, is reached when in the middle, somewhere in the middle. See how the shape is always a curve like that, like a small hill or a mountain here as well. Even when the procreate ratio is 4, and then increase to 5, and then increase to 6, we can come back to this, and then let's have a look at the next row, since I think this will save us time. In the next row, it still is the same. We still have this nice mound. What is this shape? What should I call it? Should I call it convex or concave? Depends on how I look at it, well. Yeah, it's a curve. It is a curve, but if it is a concave graph, but then usually if it's a lens, it's a convex lens. But anyway, so concave. Let's just say it's concave. So concave here, another concave here. Of course, there are always some irregularities here as they oscillate sometimes, but I think that can be attributed to the luck, since I have already for many times established that a lot of this is also about luck, and the purpose of doing this is to kind of hedge my bets, optimize my bets or hedge my bets, given that everything is still based on luck. So even when the chill ratio is increased to 20, it's still a concave. They're all concave. 30, concave. Let's zoom out. Concave. So this is the first row is when chill is at 0, and then it's 10%, and then 20%, and then 30%, and then 40, and then 50. Another thing to another interesting thing, or something kind of obvious if we think about it, is that if there's no learning, as in the learn event ratio is 0, then the tail end is always lower than the beginning, where some form of mutation happens but a lot of learning happens. But since there is so little mutation, not many entities end up diverging from the rest, meaning that they don't really improve and evolve over time. As in, there's always about 1% of entities that are evolving. But then again, it's the 1% of entities who are susceptible to mutation, but every gene or every entity would have a different mutation rate depending on the on their current ranks, right, at any given time step or blip. So this 1% is actually a lot lower than it is, or than it seems. But even then, if there's no learning, the maximum ever in that case is lower in almost all cases. Like that, look. Oh, a lot lower here. A lot lower. Yeah, lower. So that's kind of obvious if you think about it. Slightly lower here. I don't think I need to go on. So that's that. Okay. Let me get rid of this again. Reinvite the thing. Now, what did I put these red vertical lines for? Now these vertical lines are when this vertical line, for example, is when the maximum ever was the true ceiling, and out of the 240 times in this case, I've had 3 of these occurrences. 3 occurrences. 3 true ceilings, let's just say. Which is it's like 1 in 80, and 1 in 80 is like 1.25%. Let me use the calculator. Yep, it is 1.25%. Given the all the other hyperparameters. So in this case, I think I forgot to mention the max blip was 100, maximum final population size 100 as well, and it was just chaotic. No dynamic here, not yet. So no dynamic, and the number of sand grains that were created per blip was 2 times current population, and the base mutation rate was 0.01, meaning 1%. And what else? And the elite percentage is 20. But I'd said this, but the others I didn't mention. Sorry about that. So population and blip, both 100. And then the sand grain multiplier is 2. So this is when I had a true ceiling, and in the entity event ratio that gave me that was 31, 24, 5, and 40. Wow. Kind of amazing that if you think about it, the chill ratio is at 40%. But when the chill ratio was at 0, 10, 20, and 30, no entities ever hit the true ceiling, which is odd. Anyway, and then the next entity event ratio that gave me a true ceiling was 16, 31, 3, and 50. And then the next one was 25, 25, 50. Cool. So three event ratios. Okay, cool. Now let's have a look at the other one, which were done using the same hyperparameters. So absolutely the same, and in this case, yep. In this case, there was only one entity event ratio that gave me a true ceiling, and in this case it was 53, 43, 40, and 4, and then 0. Okay, but none of them actually managed to give me a true ceiling. But which would lead me to wonder, well, what if I wanted to also compare the average of each of these 10 entity ratios. Compare this to this, this. So I averaged everything out. And that is, for the first one, is this. So for the first one, here we go. So for the first one, so we have the second last one that gave us a true ceiling. Let's just mark that. It is this one, and then the fourth last one, which is this one, and then two before that, it's this one right here. So these three gave me the true ceilings, but if I were to average these out, this one was the highest, meaning this one had the highest. But this is not really a mystery. Well, because the procreate ratio, event ratio, is 3 here, and then it's 4, and then 5, and then 6. So naturally, the average of maximum evers. Wait, no. I'm not averaging them out. I'm not dividing the scores by the number of entities. But somehow, there is that tendency. Let's have a look at this one. So this is for the, oh god, this is for the second one. This is for the second one, and the second 10 entity ratios gave me. So it's this one. Oops. So it's this one right here that gave us the true ceiling. Huh. Let me get this straight. It is the average of 10 maximum evers from 10 iterations each. It is the average of 10 maximum evers, one from each iteration using one entity event ratio. So yeah. Oh yeah, no, I get it. No, it makes sense. There. Lower. 200 lower. Nope. 200. Yup. Nope. 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 Okay. Okay. Oh, that's why. So, the average seems to, the maximum ever average seems to be highest when the procreate event ratio is lower, because when that happens, the first data point is always high. Well, is almost always higher than the last one. not in this case, but in many other cases, yeah. Since all these are the same y-axis, that's why this is happening. Except maybe here, and then it's no, actually the same. Yeah. Okay. Anyway, give me this one again. This is much better. So, we've had 3 iterations from 40 and 50 for chill ratio that gave us the true ceilings, and then here all of a sudden we have from 0 where chill ratio is 0, and it gave us a true ceiling. So it really is, based on luck, or luck plays a crucial part in this, especially when the population size is so small compared to before, which used to be about at least 400. Next up, let me just take a sip of water as well. Oops. Where's my water? So, I'm back. Still drinking that water. Here we go. This is still kind of the same, except the ReloLike has been changed to flat, and it the elite percentage is still 20%, and I did this twice, so this is the first one of the two, and as you can see, we still do get all the concave shapes, but sadly, out of the 240 iterations, there were no true ceilings. Sad, right? And I know from all the other test runs, all the other runs that I've done, I know from all the other runs that I've done that if I were to increase the population size or increase the number of blips, then yeah, it is more likely to get true ceilings, but at least for now, no. Given these hyperparameters, for now, no. So that didn't happen in this case. So I would like to know the average of maximum errors, and in this case, you can clearly, this is 10%. No, what? This is when chill ratio is 0, and then 10, 20. I'm referring to the points starting from the blue dotted line, and then 1, 2, 3, 4. That's 30%. From here, 1, 2, 3, 4. That's 40%, and after that, 50%. Chill ratio. Chill event ratio of 50%. Anyway, here we can see that there is a general trend of everything going upwards. Yeah. Oops. And this is 3, 4, 5, 6. Procreate 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. Okay. The pattern here still kind of stays the same, and by that I mean the average of maximum errors being the highest when the procreate ratio is at a lower point, lower value, except maybe here. Yeah, except when it actually starts. But then again, this is because of the fact that this very first one is always when the mutation ratio is at 1%. This is m equals 1. M equals 1%. So it's really hard to for anything to actually no, well, not exactly, because even because this is also when it's at 1%. So is this, and so is this. Huh. Oh no. 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. 3, 4, 5, 6. Yeah, actually the trend is a bit different here, isn't it? I misjudged. 3, 4, 5, 6. But it is still, there is still a high degree of randomness being played. Although you can kind of see the trend. It's not such a strong correlation, is it? Yep. And then what is it? Maximum. Can I make this bigger? I know I can. How do I make this bigger? Can I make this 20,000? Then 10,000. There we go. That's what I like to see. And here is the second time I ran with everything being flat and 20%. It's the second run with the same hyperparameters, but even here I don't. Even here we can still see the concave shapes of maximum errors plots, maximum errors plots, maximum error plots, I should say. Anyway, so still see the concave shapes, but here no red vertical lines, nothing there. So no true ceilings again, which is sad. So let's bring up the average of maximum errors, and again we do see that trend going on, but it is still quite random. Yeah. The maximum average tends to be, or is the maximum ever average, or the average of maximum errors, is more likely to be higher with lower procreate event ratio. It's not always the case, but it's likely to be lower, likely to be higher. Maximum higher. No, it's the other way around, sorry. Now, let's see if that's right. Yeah. Maybe not so much here. Yep. I think it's safe to say this. And that's because that may be due to the fact that why? Why? Let's have a look. 3, 6. Because if it's 3, if it's 3%, that's doing so. I have a feeling, but it might not really be the case. I'll need to dig into this. I need to get deeper into this as well. Yep. So for now it has. Yep. So, I think I need to end the video here because I can't go on unless the video be 3 hours long. In my next video, I'll have to talk about the number of data points, the time taken, and also go through the world summed utility plots and the entity distributions. Maybe I'll need to do 2 or at most 3 more videos after this. Yeah. Depends. That would really depend. Okay. Thanks for watching. Sorry I'm leaving like this, but it is a lot to cover in one video. Okay. Again, thank you for watching. See you next time. Bye.